What's up guys, it's me Nihat again. So it's been a while that I didn't prepare anything for my YouTube channel, and yesterday I found this little guy which is pretty cool termoresistivity from my old laptop's battery. So I come up with idea to create a thermal resistivity, or let me correct that, thermal sensor for Arduino projects. It's incredibly important in some cases that we have to create some appropriate conditional thermal resistivities, thermal sensors. So we need just thermal resistivity, which is here, and I'm going to range my resistivity by utilizing my multimeter. So let's continue this issues, and we need for this project an Arduino, of course, as obvious, thermal resistivity, and in some cases we also maybe utilize an ordinary resistor. So let's continue with judging our resistivity. As I mentioned, we're now rating or measuring our resistivity. This is the thermal resistivity, and it changed its range, as I was seen here, from the temperature of environment dependence. I soldered these little wires for appropriate connections. So when I touch this resistivity, it changes from 10 kilo ohms to 9 kilo ohms. Let me just illustrate this little example, which is situated here. My computer's cooler, and it is a bit hotter than the normal environment. So when I plug in, my resistivity's value dropped to the 3. When I push it back, it gradually changes and increases to the 10 at a normal temperature of environment. So this is the basic of and the knowledge theoretical sides of our project. So we need the real experience with Arduino, which is appropriate, and I'm going to utilize a resistor, which is incredible and indispensable part of our project, Arduino Mega, and USB port, a series port, which our sensor will get values from our temperature sensor, which is thermal resistivity, and we'll give these values to our computer by utilizing serial port. So let's move on. So as I told, I assembled this little combination of elements. As we see here, this is our thermal sensor. I connect the resistivity in appropriate condition, and this is our Arduino Mega board. So let me just utilize this little example here and the circuit, which is appropriate for all of us. This is, as we see here, the 10 kilo ohms resistivity. I connected with the in an analog input 0, and one of the pin of our thermal resistivity is go to the same direction as well, and 5 volts and ground. This is the main schematics of our circuit. Now let's just see how our circuit works, and we'll continue on our basis. Also, I would like to emphasize that I will upload all these codes and a little file to my website, which will illustrate it below of our YouTube channel's video. So let's move on, and let's just check the appropriate work of our project. As we see, we have 24 Celsius degrees as our room temperature, but let me just emphasize that this is not exact rate, and we have to adjust our temperature rate to our voltage values, because Arduino only gets a voltage values from our thermal resistivity, which is to 8 here. Yes, and let me just touch with my hand to the thermal resistivity, and we can see that the temperature is gradually going to high rates. So we get, even we have to it's not exact value, but let me just emphasize that this is the temperature of my body, and when I put my hand off, so temperature decreases. This is the real and not just appropriate, I know this is the exact way of the working, but if in case of appropriate adjustment with the temperature, with the value of the voltages which Arduino gets from the thermal resistivity, it will work surely enough and accurate way.